Again, this is Mr. Bonet for AP Calculus AB, limits, one-sided limits part 2. Okay, so basically more of the one-sided limits. This time, notice that there's no absolute value. Well, in this case there is, but there's no piecewise functions. Okay, so this is just like straight up if a question is being asked where you have to choose one side. Okay, so in the first one, it says when x approaches 2 from the left, notice that if I plug in 2 on the numerator, I get 4. But on the bottom, a number is smaller than 2, it's just going to make this a positive 0. So 0 from the right, and we already know from the previous video that that's equal to positive infinity. Okay? If it would have been 0 from the right, 2 from the right, and this subtraction would have given you negative 0, which would have giving you negative infinity. Okay? Now, on here, we plug in 4 from the right. Notice that plugging 4 from the right or from the left has no influence. Well, it does. No, it doesn't. It has no influence on the value of the limit because there is no 0 over 0 or any of that in here. So it's just plugging in 4. 3 times 4, 4 squared minus 4 gives you 12 over 16 minus 4 is 12 over 12, which gives you 1. Okay? Now this one, if you saw the first video, you have a conjugate. I would suggest you do the same here. So let's multiply by the conjugate. Let me just, instead of rewriting it, let me just go straight to the multiplication, and let me change my colors as well. So the conjugate of the denominator is 3x squared plus 1, and then plus 1 outside. 3x squared plus 1 and plus 1 outside. Okay, notice that before I multiply by the conjugate, I should have checked if it gives you 0 over 0, and it does. If you plug in 0 here, you get 0. You plug in 0 for x, you get 0 in the bottom. So this is where we have to use the conjugate rule. Okay, now do not distribute the top. On the bottom, if you saw the first video, you're going to see that I'm going to jump the step of the FOIL. Okay, I suggest you watch that one to understand what's going on. But eventually, you get the rhythm that it's just going to be the first term squared minus the second term squared. So if I square the first term, I'm left with 3x squared plus 1 minus the second term squared is just 1. Okay. So now we keep going, we simplify the bottom. Notice that the plus 1 minus 1 gives you 0, so you're left with 3x squared, and that's what I want. I want to get rid of the x squareds. So we get rid of the x squareds, which is what's giving me the problem. And you're left with the square root of 3x squared plus 1 over 3. Now we plug in 0, you get square root of 1. So square root of 3 times 0 squared is 0, plus 1 is 1, square root of 1 is 1, so 1 plus 1 over 3 gives you 2/3. And that will be your answer. For this one, notice that it's asking for 0 from the right. First, if I plug in 5, I'll get 0 over 0, so I need to factorize the bottom. Okay, so x minus 5, x minus 5, x plus 5. I can get rid of the term x minus 5. Now you're left with x plus 5, which gives you 1 over 5 plus 5, which is 1 over 10. Okay, notice in this example, from the left and from the right, it's still going to give you 1 over 10. Here, same situation from the previous example. Okay, so you got 2 minus x. I'm going to, the first thing I want you to do, just like on the first video, is factorize a negative 1, and I have x minus 2. And then in the bottom is x minus 2, x plus 2. Okay, we can get rid of those terms. So now we have when x approaches 2 from the right, of negative 1 over x plus 2. You plug in 2, you get negative 1 over 2 plus 2, which is negative 1/4. Now here is important to notice the absolute values. Okay. Now remember, this is a piecewise function whenever you have an absolute value. Okay. So this is going to be x minus 2 over x minus 2 for x greater than 2. Notice that I don't include 2 because it can't give you 0 in the denominator. And then negative x minus 2 over x minus 2 for x less than 2. You can simplify that. 1 for x greater than 2. Negative 1 for x less than 2. Since we're looking for the limit when x approaches 2, notice that from the right is 1 and from the left is negative 1. Therefore, the limit does not exist. Okay? Does not exist. For more information about that, look at the previous video. Okay? Here, we factorize the bottom. Notice that we're going to factorize the bottom for a specific purpose, and you'll see why. So 3x over 4 minus x, 4 plus x. Okay. Now, if we are approaching 4 from the left, that means that it's an infinitely small number, smaller number than 4. So when I plug that into this one, okay, I'll have 4 minus a smaller number than 4, which is going to give me a 0 from the right. Now this is not going to be affected in this one either. So it's going to be 12 over 0 from the right times 8. Okay, that's going to give me 12 over 0 from the right, which is going to give me positive infinity. Okay, and that's the purpose of doing that. Now, the next one, here we factorize top and bottom. Notice that if I plug in 0, I have to check that it doesn't give you 0 over 0. In this case, it gives you negative 7 over 0. Therefore, I need to be careful with the infinities. Okay, so I don't have to factorize the top, I only have to factorize the bottom. So x squared minus 7 over x times 3x squared minus 2. Okay, if you want to go a little bit factorizable, you can keep factorizing that. Okay, x times 3x squared minus 2 is going to factorize into radical 3x minus radical 2, radical 3 x plus radical 2. Okay, now again, this is going to give me 0 in the bottom. I need to identify if the limit exists by choosing both directions. So I'm going to choose first when x approaches 0 from the left. If it's 0 from the left, again, the numerator does not get affected. It's just negative 7. Let me just write the entire thing. Well, I don't want to write the entire thing. It's too time consuming. It's just, I'm going to write the limit when x approaches 0 from the left. Now I'm going to apply it. So it's going to be negative 7. 0 from the left is going to be 0 from the left here. 0 from the left is going to be negative radical 2. Oh, so I didn't even need to do any of these factorizations because that's going to give you negative 2. But 0 from the left is going to be negative infinity, but negative over negative makes, wait, so this is negative 2. So, okay, this is going to be positive 7 over 0 from the left times 2, which is going to be negative infinity, okay? Then 0 from the right, I know it's messy, but stay with me. It's going to be negative 7 on the top. It's going to be 0 from the right on the bottom times negative 2. Negative over negative is positive, so it's going to be 7 over 2 times 0 from the right. That's going to give me positive infinity. Therefore, this limit does not exist. Okay? So, does not exist. Now here, 0 from the left of this expression, I would just try to find a common denominator. Okay? So 3x minus 2x squared over, actually, common denominator is much smaller than that. Just multiply by x under 2 over x. So, okay. Three over x squared minus 2x over x squared. Okay. Now here, notice that 0 from the left, okay, it's a negative value. But this becomes still positive 3. And a negative times a negative makes a positive. So this is going to be positive from the right, 0 from the right, which is just positive infinity. Okay? And that's your answer, because it's only looking for 0 from the left. 132 is interesting. It appears a lot in the AP test, so you might want to focus a little bit more on this one. It says, if g of x is this crazy piecewise function, then find the values of m and k such that both limit of 1 and negative 1 exist. Okay. So we have to divide it into 3 parts for 1 and 3 parts for negative 1. Well, actually just 2 parts, because we want to force it to exist, so the limit from the left and from the right have to be equal. Oh, what happened? Oh, okay, so x approaches 1 from the left. If it's x left of 1, we're choosing this one right here, okay? This is x less than 1. So we're plugging in mx minus 2k. So you have m times 1 minus 2k, which is just n minus 2k. And then the limit when x approaches 1 from the right, okay? If it's 1 from the right, we're choosing this one. So 3x squared minus kx plus m. We plug in 1 for x only, so 1 squared minus k times 1 plus m gives you 3 minus k plus m. Now, in order for this one to exist, these two have to be equal. So m minus 2k has to be equal to 3 minus k plus m. Okay? By doing that, I'm going to have k in terms of m or m in terms of k. It doesn't matter. Okay? So I'm going to move this one this side and this one this side. So m minus m equals 3 minus k plus 2k. 0 equals 3 plus k. Therefore, k equals negative 3. So we found k. Now we need to find m. So we're going to apply the same principle for this one. So I'm going to change my colors a bit. So now we choose the limit when x approaches 1 from the left. If I choose the 1 from the left, I'm going to choose this one, so negative 3m plus 4x cubed k. We plug in 1 for x only. Negative 3m plus 4 times 1 cubed. Now k, we already know what k is negative 3, so we can plug that in, negative 3 as well. We've simplified this, so negative 3m. 1 cube is 1, 4 times negative 3 is negative 12. Now we're going to do when x approaches, this is negative 1, by the way. When x approaches negative 1 from the right. Okay, I'm going to use the middle one again. So mx minus 2k. So it's going to be m times negative 1. Actually, this is negative 1. So this is plus 12. Okay. Minus 2 times k. K is negative 3. So it's going to be negative m plus 6. Okay. Again, these two have to be equal in order for the limit to exist. So that means that negative 3m plus 12 has to be equal to negative m plus 6. We simplify that, we get negative 3m, we move this one here, and then this one over there, plus m equals 6 minus 12. Negative 2m equals negative 6. We divide, so we got m equals negative 6 over negative 2, which is positive 3. So m equals 3, k equals negative 3, and that's your answer. If you like the video, please subscribe to MultiWow, share with your friends, share with people who are taking the AP Calculus test, and let me know what you think. Thank you.